Hi friends, this is another session for Advanced Assembly Single Cylinder IC Engine, which includes the assembly of IC engine components using mates and relations. Also we will see the motion study as you see on the screen. Before starting this session, I'm strongly recommending you to watch part 5.1 of the video tutorial series. It's explaining different kinds of mates in very detailed manner with examples. In this session we will use different standard mates, advanced and mechanical mates as well. Let me show you the commands from video tutorial 5.1 which we are going to use for this particular assembly. Go to the tutorial part 5.1. Here is the assembly. You can go to high definition, then go to the description. Here you can see that all the commands are listed 1 2 3, including insert component, all different kinds of mates, then the assembly evaluation, bill of material, explorer view, etc. You can click on the timeline to watch the individual parts. In this particular assembly we are going to use all kinds of standard mates like coincident, concentric, parallel, perpendicular, distance, angle, everything from standard mates. From the advanced mate we need to use symmetric mate and width mate. From the mechanical mates, cam and follower mate, slot mate, gear mate are using for this assembly. So I'm strongly recommend you to watch this one individually by clicking on the timeline so that it will be easy for you to assemble the component. The parts for this assembly I directly downloaded from GrabCAD. I would like to show you the biggest online design community, GrabCAD. If you're really interested in design, GrabCAD is the best platform for you to develop. You can share your work and discuss your queries with millions of experts, and the best part is this is completely free. Once you log in, you can select your software and it is listing almost every software CAD. So I'm selecting SolidWorks. Okay, so it will list millions of different work from different people and you can search over here. And the best part is there is a question tab and you can use this tab for asking questions. Here also you can go for specific software. You can select SolidWorks over here. So it is very much useful. Make maximum use of it. Here we go. So this is the assembly. All the parts are listed with the quantity and we can identify the parts from this diagram. And there are some other informations relating to the distance between crank and the rocker arm location, push rod location. Okay, we'll start with the assembly. Go to new assembly. Yeah, the 2018 version is directly giving the insert component. If you're using the older version, you can start from insert component and then you can browse. I'm starting with the crankshaft. As we all know, the first component will be a fixed one, so you can make it floating because I want this to rotate in an axis. For that I'm going to create an axis in the origin. Go to reference geometry, click on axis. I want to create an axis in the origin which should be perpendicular to the right plane. So I'm selecting the right plane also. Here we go. Here is the axis, and in order to show the axis, visibility, click on this one, it is showing. Now we can go for the mate option between this one and this. It is not moving because the crankshaft is fixed. You can make it float. Go for the same option now. So in order to align more, we can take the right plane of the crank and the right plane of the origin, so it will be aligned. Perfect, and it is having an individual motion now. We can see that. Now we can go for the other parts. Insert component. I'm selecting connecting rod, piston and piston pin. So in IC engine we can see that the big end of the connecting rod is connected with the crankshaft and the small end is connected with the piston by using piston pin. So we'll go and select these two faces, go for concentric. By using the width mate we can make it exactly in the middle. So I'm going for the width mate. It is coming under advanced mates. As I mentioned in the beginning, if you want to review any of the mates, you can go and check video number 5.1. I'm selecting the other two faces, that is called the tab sections. Then it will automatically come and inserted in between. Now we can assemble the piston. So I'm selecting this face and I need to select this one should be coincident, and we can also make these two. Okay, now it is perfect, and we can add the pin also. The pin is now concentric. The length, you can see that the length of the pin is not exactly same to the size of the diameter of the piston, so you can use tab also here. Go to advanced mates, go for width, and this is my width section from here to here. The tab section is this one. Okay, so that's all. Now we can call the next part, that is part number 4, camshaft. There is a position arrangement for the crankshaft and camshaft, having a horizontal distance of 65 and center to center distance of 97. So first we can call the camshaft. It came inverted, so we can use the rotate component. So I'm rotating it. First we can make these two faces coincident. Now we need to make this drawing. Here is the 65 and 97. So I'm selecting this face for sketch. Now from here, make sure that these two lines are horizontal and vertical. This is 65 and this one is 97. Exit the sketch, select the curved area and also the point, go for mate, concentric one. Okay, now it is fitted over here. Now we can call the gears, part number 5 and 6. We have the small gear and big gear. So first I am arranging the gear over here, concentric, go to mate. And also the coincident relations between these two faces. And I can also use the lock option over here. So see, for that one I am selecting this edge and also this edge, so it will be locked over there. Same over here also, I'm selecting these two faces, concentric, these two coincident. Then here also we have, select this particular edge and this one. So here is the gears. Next part I am calling is part number 8, that is a shaft, the rocker ram shaft. So insert component, here is the shaft for the rocker ram. Okay, I need to rotate it. For that one, go to rotate. I can rotate this one in this way. Now here we can see that for the shaft, the rocker ram shaft, we have a location. We need to start from the center at a height of 340. For that we need to select the right plane, so I'm selecting the right plane now. Go to right plane, go for sketch, because it is happening in the middle. Now we can draw the center line from here. Make sure that it is vertical. Yes, and this must be horizontal also. Go to smart dimension, the height is 300 and the horizontal length is 40. Now we can create an axis over here so that it will automatically align. For that purpose we can go for the same option, go to assembly, go to reference, first exit the sketch, reference axis, selecting this one with the right plane, so we'll get an axis over there. Now we can use this axis for making concentric relation with the shaft. Click on the axis, go for mate. Okay, now it is concentric automatically. Now we can give a coincident relation between the, so this is the assembly arrangement for the shaft. Now we can align the piston also. Here you can see that the piston is moving in different way. So what we need to do is we can select this edge or this line and also this curve. Go for the concentric relation. Okay. Now the movement of the piston is restricted through this axis. So you can see that the real motion over here, see, it is actually working with the same principle of the piston motion. Now we can call the next component. Now we will call for the other component, which one is a rocker arm. Okay. We can make a copy by press and hold the control button. Okay. Now I need to rotate this one. Okay, now we can fix it over here by using concentric relation. This one also. Now coincident relation between these two faces, so it will come closer. This face. Okay. Now it is having this motion. Now we can go for the next. So next part in the assembly is item number 10, that is push rod. Here we can see that the push rod is exactly in the middle of the camshaft. For that purpose, here is the location. It is 15 mm away from the center, and we need to create a plane which is going through the axis of the camshaft for locating this one. For that purpose, we can create a new plane. Go to reference geometry, plane should be parallel to the front plane but going through the center of the camshaft. So the plane is ready now. We can go for the sketch. Make it normal. Okay, we can draw make sure that this line is horizontal and these are vertical lines, and the distance between these two is 30. It's given in the question, and also the gap is 15, so it is equal in both sides. Now it is perfect. Exit the sketch. Now we can call the push rods. So we need to press and hold the control button and make a copy of that. Now we can use the same method for, should be concentric, and the other one also. Good. Now we can see that this particular portion should be exactly in a vertical manner. For that purpose, we can select the reference planes, go to the right plane, Then we can go for the right plane of the push rod. I'm selecting the right plane of the push rod. Give a parallel relation. Okay, it is automatically parallel now. Here we can see the difference. If you are zooming this one, you can see the difference. So now it can move only in this way. This cannot rotate. Same thing over here. Go to right plane and also the right plane of the push rod. You can see that it is rotating and making a lane with the plane. So now it's fine. So we have these two now. Now we are going to give the next relation. Go to mate. Go for mechanical mate. Here we have the cam mate. So cam is asking for two things, cam path and follower. So I'm considering this as my path and this as the follower. Click OK. This one is fine. There is no error actually. Now the same thing again. Go for cam. This is my path and this is my follower. Perfect. Now we can see the relation over there. If I am rotating the gear, see, it is giving the same mechanical effect between cam and follower. Now we can give the relation between push rod and the rocker arm. It is a tangent relation. Go to the mate option. We can select this face and also this curved face, so it will automatically give a tangent relation here. Here also. Okay, and this face, so it will be tangent. Now when it is rotating, see, as it is tangent, it will automatically operate the rocker arm as well. Now we can go for the next part, that is the valve part over here. So item number 11, 12 and 13. See, the position of the valve assembly is over here at a distance of 200, the same distance apart. So for that, what we are going to do, we can save the assembly, current assembly, and go for a sub assembly. So I'm saving this one, rebuild the component. This is, you see, now I can start a sub assembly. I'm minimizing this one. Open a new assembly, browse the components, valve, retainer, valve spring. Okay, now I'm making the retainer floating and the valve fixed. Okay, now concentric relation between these two, and it is fitting over here by a coincident relation. Good. Now we can select the inner surface of this one and this. It will automatically fit over there. So this is the simple sub-assembly for the valve. I'm saving this one separately. That is valve sub-assembly. Okay, can close this one and we'll go back to our case. Here we can see that the location of the valve sub-assembly is 200 mm apart at a height of 200 mm height and 30 mm apart. So we need to make a new geometry over there. For that, I'm selecting the front plane. Go to the front plane, go for sketch, spacebar, make it normal. So I'm making a new drawing over here, so we can use this as reference. And height is not a matter because we are going to give the concentric relation between these two. The distance between these two is 30 and equally in both sides, and also we have a constraint. It is at a height of 200 from the center, so I'm giving 200 also. Okay. Now we can exit the sketch and call for our subassembly. Here we go to insert component. I'm calling the valve assembly here. Okay, now select these two and go for concentric. Okay, and we can call the valve assembly again. Same option here also, concentric. Now we have the tangent relation between the top faces. For that, I'm selecting this face, tangent with the surface. Go to mate. Okay, same thing over here also. I'm selecting this and this. It will select the tangent relation. Here we go. Now we can check the relation. See, we can see that the rocker arm is actuating the valve. Now we can go for the last mate in this assembly, that is the gear mate. Before that, we can align the gears properly. So okay, now go for the gear mate. It is coming under mechanical mates. Go to gear mate. The gear ratio will be selected by the software itself. We need to give the pitch circle or any circle diameter relative. So I'm selecting the outer addendum and also over here. So here we can see that the ratio has already selected. Click OK. Now okay. Now we can hide all the extra sketches. Also we can hide the axis. Now we can rotate the component. So now all the components we can see that working perfectly. So this is the full assembly for IC engine. Now we will go for the motion study. Now we can animate our assembly by using the motion study, which is available in the lower tab. Or if it is not available there, you can click on the ribbon over here and activate the motion manager. It is already available for me. Now we need to go for the setting, and I'm increasing the frame to 25. Now all the relative motions are available there in the assembly itself. So the last step is to give a motor. I'm selecting a rotary motor and connecting over here in this particular surface with a 25 RPM. And I'm increasing to 20 seconds so that we will have a smooth motion. Now calculate it. It will take a few seconds, depends upon the complication of our geometry. Here we go. Here we can see the motion, and we can also give a rotation so that we can see all the phases and relative motions. For that, we can go to animation wizard, rotation y-axis. We can select the axis of rotation. It is starting after 2 seconds. The duration is 20 also. Okay. Now so this is the completed assembly of single cylinder IC engine with the motion study. Now the last step is generating bill of material. Here it is. You can click on bill of material. I'm going with the BOM standard. You can edit over here the different options. Okay, existing annotation view. So I'm removing the extra column now. So we can increase the size, and also we can adjust the font and okay, here it is. Now if you want to balloon individual components, we need to go to the drawing option, make drawing from the part. So I'm selecting a sheet, a blank sheet. So here we have all different views, front view, side view. You can have the sectional views also. Now I'm selecting the current view. Okay, now we can give the scale. I'm giving 1:2 so that it will fit in my sheet. Okay, now here also we have the bill of material. The same way we can call this one, and delete the column only. Now can increase the size. Okay, this is fine now. Now go to the balloon option and you can select individual component. That will automatically give the numbers. So starting with the piston, so individual parts, here we can see the pin is inside. Now connecting rod, camshaft, here we have the gears, now the rocker arm. The same way you can complete all the parts, and finally we can save this as a PDF. Once we complete everything, go to save as and as PDF. So that's all about IC engine assembly. Thank you for watching. See you in the next session.